Hey guys, what's up? This is me again. Today we're going to be discussing another assembly language program, which is basically memory block transfer with some instructions. So like string string instructions as well as the non-string instructions, right? So first of all, let's just see what memory block transfer actually even means. Consider there is this kind of block of memory over here. We have written something, right? In this is probably in the data segment. I mean, it has to be in the data segment. It can be in the extra segment as well. But in the data segment, you have like a set of variables which you have maybe already defined, or there's some space reserved. And maybe you want to transfer it to some other part of the same data segment, maybe somewhere like this. Now this is over here. You want to transfer it over here in this space, or you want to transfer it to some different data segment altogether. We'll say DS2. This is DS1. So that is what you call memory block transfer. Basically, it's just what it says. Transfer the entire block of memory into another block over here, or into a completely different data segment. Yeah, also the question over here does specify that block containing data can be specified in the data segment, right? So that's that. We'll just okay. Oh, also I'll be switching to light mode for now, because apparently it's easier to be seen. First of all, we'll start with our data segment section, data section. Okay. Over here, we'll need to define our source block as well as the destination block, right? So first we'll define our source block. We'll say DB, and you can put anything you want. I'll just put 1, 2, 3, 4 like that. So 0, 2 H, 3 and 0, 5 H. Also, the H over here represents the hexadecimal, right? And I'll be defining destination block here as here itself. Hey guys, this is editing Ayush here. Just wanted to clarify, please don't put your DST block in section.data, put it in section.bss. I've actually suggested this method in this explanation itself. So go with the explanation which I give later. The first one will actually result you in a lot of pain and suffering, which I will actually go through in the video later on. That's all. That's pretty much the basic logic. If you want, what you can do, guys, is take the destination block in your section.bss and the length of this. So you can do like SRC block length, and you can equate it to, the length of SRC block, right? So you can do this and then use this length to kind of reserve the number of bits for destination block. You can do that. But I mean, it's the same only. Like the number of bits that are reserved is the same. So I'm going to go with this. You can do it either way. Yeah, then we'll first have like our menu message, right? Because it's a menu driven program, which is going to be db um, enter choice. choice, right? We'll say one for without or non-string operation, and two for string operation. Fine, fair enough. So basically, that's like memory block transfer operations are of can be done in two ways as well, right? One is using your MOV and one is using your MOV SB, which basically is a string transfer command. Then I'll actually just quickly write some like basic messages for input and output. So yeah, you can write those with me as well. By the way, just to revise on the concept, EQ is basically equating like a given value to a variable. So that what that basically means is that now OP message to length is a constant. You can't change its value. If you change its value, like you'll get an error. Right? So now these lengths have been defined. After that, we'll go and we'll define. I think yeah, we won't need any more messages now. We'll just go into section.bss. So BSS section. Also, I think it's like a neat practice, right, to like separate out the sections so that if there is some compilation error, you can like not for this program, but in the coming programs, it will be great if you follow this as well. Because in the coming programs, we're going to have much longer kind of code, right? So yeah. Anyways, so we've defined our a answer, which is basically going to be uh, so we're going to convert this hex value into ASCII value and then print it one by one as it is in the block, right? So for printing, this is going to be like our intermediate variable. Then this is a counter. I'm pretty sure everyone's familiar with that. And in the BSS section as well, we'll write some macros. Now, here's the thing, okay? You can write macros at the start of the program as well. That's completely fine. It's just that uh, we apparently it was told to us by our teachers to kind of write the macros in section.bss, but you can write it in the start of the program as well before any statement. That is completely valid. Right? So this is just a basic uh, read write procedure. No, sorry, not procedure, macro, and move RDI one. Oh, what happened? Move RDI one. Move RSI, which is source index register. This is going to be the name of the variable, and this is going to be RDX, the length, and then end macro. Also, yeah, we're going to learn something new about macros, which you might have. I'm pretty sure that you guys might not have seen. Also, syscall, haha, calling your sister. Then this was just basic. Now we'll get to the actual kind of tricky part in this. Okay, so in macros, this macro which I am telling you now, which is uh, macro print array. Okay, wait, I put a space. macro print array or print ar2. Let's just say print array2. Uh, we're going to move the RSI to 1. This is basically going to print the array which we tell it to print, right? So we have our block of memory over here, right? The source block and destination block. So it's going to print those blocks over here. So that's what we're going to use. That's this is where the answer variable will come, as we are kind of converting the hexadecimal characters to hex ASCII characters. Yep. Um, Now over here, move RSI, and then we'll move byte of CTR, and we'll move the second operand inside it, which will be the length of the array. Okay. Now here's the interesting part. If you want to have a loop inside a macro, then use two percentage signs and say like the name of the label which you want. So I'm calling this label as repeat. Also no colon, right? Just this is your label. Now we'll write move al comma contents of RSI or the memory location pointed by RSI. And we'll push RSI to the stack. Why is that? Is because now you're going to call display. So you might remember from our previous videos that display is a procedure which converts hex to hex ASCII, right? So we're going to call this, and the reason I pushed RSI is now we're going to say RW 1 comma answer and then 2. So we're printing the answer, right? As this method basically is going to work on answer. So in RW we are kind of putting another value in RSI. That's why we have to push it to stack first and then pop it from stack so that the value of RSI is not actually changed for this particular macro, right? So pop RSI, then we need to increment RSI so that it will print the next element, right? Oh, also, what we can do over here is um, before popping RSI, we can move. Basically, what I intend to do is to print another kind of next line character with like the answer. So we'll move 10 to answer and then we'll print it, right? So print 1 answer and 2 because it's 2 bytes in size. Right. So so basically this is going to print new line, prints new line. Don't worry, like I'll upload this code on GitHub along with I'll comment it out as well. In the end, we'll comment the code together because it's like a good practice to comment your code, and it will definitely be beneficial in your practical exams if you kind of do that. Now we'll decrement the byte of CTR, which yeah, that's correct, and then we'll do J and Z. Now over here, see, just use this, copy this and paste it here. That's it. You leave the double percentage signs alone, right? After that, just this macro is over now, so we'll do end macro. Right, now this is done. Our print array macro has been completed. Now I'll just define another macro for exit, right? Pretty sure you guys have seen this, exit 0. So move RAX, comma 60, move RDI, comma 0, and then call your mother to see what you're doing on YouTube. What are you doing on YouTube, huh? Should be studying, right? Yeah, so syscall, and this is our exit macro. Never mind. Also, I'm like so bad at like making jokes because my tone in real life is just like this. It's just like dead inside. Can't really have any variations in my voice. I don't know why. So let's go to section.text. Over here, let's start with our typical global underscore start, then underscore start. Yeah. Now over here, first of all, we'll print this message, menu message, because we need a choice, right? If like what the user wants, a non-string operation or a string operation. But even before that, we'll have to print the contents of the source block. So I'll do that right now. What I'll do is over here, rw01 src block. This is our, actually no, my bad. We'll have to first print the message, right? op message 1 and op message 1 length, the contents of the source block. Yeah, op message 1, op message len, and then rw done. Now we'll have to print the source block, right? Because we are saying कि हम प्रिंट करने वाले हैं तो करना तो पड़ेगा, झूठ नहीं बोल सकते ना. So src block. So this is the macro which we defined over here, guys. So see, first is the address of the array, and the second is the number of elements in the array. So over here we have 1, 2, 3, 4, 5 elements. Wow, right? Really needed to count those out, but yeah. So we put 5 over here, and now the arrays will be printed with new line already in it. So cool. Now you'll just go rw1. Now over here we can print the menu message, right? I think I'll do the menu message later, or I'll leave it up to you guys because that's pretty easy. And like focusing on the main logic is more important, I think. Right, so now we need to print the destination element, right? The destination array, my bad. So 0, 1, comma, op message 2, op message 2 length. So over here we are basically printing this contents of destination block before transfer. You will have to print this in any case, right? So what you can probably do is display the menu message, take the choice, like uh, take choice from user, print this, and then you can probably like put compare over here. Compare, the choice. If it is 1, then jump to some place. If it is 2, then jump to some other label. So that's pretty basic. I think I won't be covering that right now. Or if we have time, then I'll cover it. No worries. So contents of destination block before transfer we printed. Now again, we'll have to print it for the user to see that we are not lying here. So this is print array destination block. Destination block. I think that's what it's called. Yeah, no, it's DST block. Okay. Yeah. Print array destination block 5. Cool, because the length of it is 5. Now, after this, we need to kind of actually transfer the like blocks, right? We need to perform block transfer from SRC block to DST block. So for that, we'll need to write a procedure. So we'll just say that we'll call procedure over here. We'll say block transfer or transfer. This let's just say this is without string operations. Okay, so without str transfer without str. Then there'll be another for transfer with str. So transfer with str. Yeah. So these two only we'll need to call. Also, after every transfer, you'll obviously have to print the array, right? So yeah, RW01, we have the message already here. Contents of destination block after transfer. This is OP message 3. Just copy that here because I'm really hardworking. Message 3. I've used this joke like twice or thrice in my videos now. Running out of shit. Ah, 01. OP message 3. Len. Okay, fine. Message 3. Okay. And after that, obviously, we'll have to print destination block. So we'll print it over here as well as here. Now, if this is not in a menu, it can be kind of like confusing, I guess, because the two destination blocks are going to be printed together, but that's okay. You guys are programmers, you can understand. So now we'll write our procedures with a capital P. Yeah. Uh, Right. So now let's do transfer without str. Yeah. Block transfer without string operations or string instructions, what I wanna call it. So what we are going to do is we're going to do move RSI source block. So RSI is the register, like source index register, right? So in string block operations, always make your source block point to the RSI. Then we've moved the address to RSI. Now move the destination, right? RDI to des DST block. Yeah, DST block. Now the source block and the destination block are in their respective registers. So that is good. And we'll move the byte of counter to 5. CTR to 05H. We'll move 05H in that because we know we have 5 elements, right? So let's just say, what did we use over here? We used repeat. So we'll probably use into label over here. Label, repeat. So label repeat, move BL, comma, we move BL to RSI, right? Uh, because like we need to move the data one by one. So BL is basically kind of acting like a temp variable here. Move BL to move RSI to BL and then move BL के contents to RDI का memory location. So RDI is pointing to destination block now. So that's what it's doing. The data is going from RSI to BL, and from BL it's going to RDI, right? We can't do this directly. Move RDI to like move from RSI to RDI. I went out because someone was at the door. Uh, okay, where were we? Yeah, decrement. So Over here, we are decrementing the byte of counter. This is pretty much done now. We'll have to now jump if not zero to label rep or label repeat. So, I mean, this is pretty standard, right? कि एक करके you will transfer elements of RSI to RDI through intermediate variable or register in this case, which is BL or like the smaller version of B. And then you put ret. Okay, done. Also, yeah, the display method, I will be, yeah, I'll put the display method later. Okay. क्योंकि I think everyone knows what the display method is. In this program, there are a few changes in the display method, but that's just like variables का कि AL की जगह BL or something like that. ठीक है, so nothing too special about that. Let's just do now transfer with string instructions. So we do move RSI source block, move RDI destination block. I'll just copy it from here because it's the same, like completely the same. ठीक है, we have RDI and RSI. Now see over here, in assembly, most of the time RCX is used as a counter by default, like in the commands. So RCX is basically going to be our counter variable over here. Now we'll clear the direction flag. Now what the direction flag is basically it's going to set the direction of block transfer. If it is from source index to destination index, the direction flag needs to be set to 0. In most cases, the direction flag is already 0, but just to ensure that it is pakka 0, we are doing CLD. Now, move SB, that's literally it. We just have to put REP over here. REP stands for repeat. What that means is it will repeat this command, move SB, until this counter reaches 0. So yeah, that's like a pretty good way, na, to like save yourself some time and write code. That's actually it, guys. Like और इसके अंदर कुछ है नहीं ऐसा. We'll go through the display procedure again. I guess we can copy it from our old programs as well. I think yeah, this was the program of the last video where oh no, this was the string length one. So this was the one, yeah, this was the one. This was uh, the greatest number wala program. I just yeah, if you've not watched that, go watch it. Click the info card or something. I don't know. Blah. Right, so this is our display procedure. I'm pretty sure like you guys are familiar with this. Now, instead of doing RBX and RAX, we'll move BL to AL. See now the reason behind this is when we were doing it in the previous program over here in P3, we had 64-bit numbers, but over here we don't have 64-bit. We only have like a 2 byte wala number. Yeah, so this is 64-bit now. 64-bit is what 8 bytes, I think. No, it's not. Yeah, it is 8 bytes.
Stop it. Get some help.
64-bit is 8 bytes. Yeah. Then we won't be using RSI because RSI is already used in the macro. We'll use RBP and we'll point it to answer. Now this everything this which this does is same. Just over here instead of RBX it should be BL, right? And over here instead of AL over here we are using DL because AL is already used. AL is actually in the macro. If we see, AL is holding the address of the array, so we can't change AL. That's why I'm using the DL register, which will kind of do the addition. Also, yeah, one of the reasons why in the previous video I kind of used this easy logic where you just add 37 and skip. There's a better and more elegant way to do this, which is now see we were using JG over here. We'll use JB right now for unsigned, right? And we'll do if it is below, if DL is below 9, we'll add 30 to it. Previously, if it was greater, then we were adding 37, right? So, and if it was lesser, we were adding 30. So here we'll add uh, DL comma 7H, and here we'll add 30 label. Okay, one more behind. Yeah, and over here comes add 30H to DL, obviously. Yep, done. So this is what the changes were. So now it's kind of you have to write less statements also, right? And one label is reduced. So your program kind of looks more easy. Add 30. So basically you'll compare the programmer will compare DL with 09H. If it is less, that means that you need to add 30, right? So it will directly jump to 30. And if it is more, it will add 7 pehle and 30 baad mein. So it's adding 37 anyways. Yeah, so that was the whole change. The major changes में also हाँ, इधर AL की जगह DL आएगा. Then we are not using RSI now. Now we are using RBP. So we'll increment RBP and we decrement to RCX or CX. CX also works fine. Yeah, and JNZ back rotate. We don't need these two instructions now. So yeah, that's pretty much it, guys. Our program is done. Like, oh yeah, also we need to print stuff over here. We'll test out if our program is actually working or not. So I'll do NASM F. Oh, also, I actually never explained the file format, right? So see, this is NASM, which stands for Netwide Assembler. The dash F over here actually stands for the file format. So if you're using a Windows machine, you'll put Win64. If you have a Mac, you'll I don't know what the code is for Mac. Maybe it's Mac or something or iOS. I don't know. And if you are using Ubuntu or Linux distros, it will be ELF64. That's the breakdown. Then we'll put our p5.asm. Okay, end of file while still defining macro exit. Oh yeah. So we didn't put end macro over here. I actually put macro over here. That's why it kind of messed up. कि label alone online without a colon might be an error. You're supposed to put a colon over there, guys. My bad. Colon हर बार आएगा. Okay, okay. So guys, see over here, I missed a comma while typing. So yeah, over here I missed a comma while typing. That's why we got these errors.
Emotional damage.
Now it got compiled without any error. Now LD, LD is basically converting your object file into an exe file, right? So I'll put p5 over here for program 5 and p5.o. If you're in Windows, actually, it will be different for you as Windows kind of uses GCC to convert the object files to your executable files. So you'll have to put something like GCC, GCC your obj file and your dash o exe or something. So yeah, you can look those commands up and at like on the web or something. Yeah, that's not like that challenging, I'd say. So yeah, and dot slash p5. See.
You didn't have to cut me off. We were nothing.
To Lamau. Okay, guys, so I kind of modified the code a little bit, and actually, this is a correction kind of. Over here, you can see I mentioned the DST block over here in data section. So I was getting a segmentation fault over here as my function, the procedure transfer without string operations, was trying to kind of modify this over here. So now, see, I really don't know the exact cause, so it's like difficult for me to tell you why is this happening. But what I did to solve it was I just did a destination block resb5. So like instead of declaring it as 000h, I just did this. I think I previously also discussed this while writing the same. So yeah, apparently this is not the correct way to go about it. So now if you see, this is the terminal. Let's actually just do them one by one, right? So you can actually see कि okay सब चल रहा है. So we'll compile this. Yeah. So see the string transfer के साथ वाला, the transfer with string instructions is working. Now we'll go over here. We'll do it without the string transfer. See, so this is also working now. The destination block. Right, so that's it, guys. And that's pretty much it. This was kind of easy, but just keep one thing in mind that over here, don't do this. Use destination block that was defined in section.bss only. Also, I'll be uploading this code on my GitHub along with all the microprocessor assignments, and I'll try to include that link in the description below because I've done some changes over here as well. Uh, those are like pretty minor. Like I've just like made sure I guess RDI था इधर या RSI I don't remember in the previous recording. I guess I did RDI over here. Basically, I just changed a couple of names here and there. That's why, because I wanted it to check it with my reference program, which I write before prepping for these videos. But yeah, this works now. So that's all.